Okay, hello students. Today we will discuss the Simpson's rule. Okay, what do we do in the Simpson's rule? We find the integral of a function numerically. All right, and you can see here from the picture what is happening in this picture. Graphical representation of the multiple application of Simpson's one-third rule. Note that the method can be employed only if the number of segments is even. All right, remember that we will strictly follow the formula number 21.18 from chapter number 21 of Stephen C. Chapra's book on numerical computations for engineers and numerical methods for engineers. And you will see here that what is happening in this picture, we have divided this domain into how many patches? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 patches. And how many points? 11 points. All right, so now the plan is that we will apply any numerical technique to find the integral or the area under this curve. All right, so the derivation is provided in the book. Today's task is to solve a question on a paper using Simpson's rule for step size n is equal to 4 and n is equal to 6, and send me the scan of that picture via Skype for today's evaluation. All right. We had a discussion this morning, but students were having connectivity issue. For that reason, I have made this video so that you can go through the contents quickly. Right. So now the point is that we will follow formula 21.18, and for the error analysis we will follow 21.19. Okay, let us first focus on the formula. What is happening in this formula, students? You can see that functional values at the boundaries have coefficient 1. And then, for example, here you can see I is equal to 135. F of xi have got the coefficient 4. J is equal to 246. F of xj have got the coefficient 2. And if you type this in expanded form, you will see that it is very easy. Okay, for example, you can see here that let us say that we have n is equal to 4. So you will have b minus a divided by 3 times n. Okay, n is the number of intervals. I can apply Simpson's one-third rule. Why? Because n is even. Okay, now remember that functional values at the boundaries will come up with the coefficient 1, and the functional values after this you will start doing this way. You will type f of a plus f of a plus h plus f of a plus 2h plus f of a plus 3h, and remember that f of a plus 4h is actually f of b. As I taught you in the previous video, b is equal to a plus nh, right? So for that good reason, f of b is better. Now you can see that the expansion of formula 21.18 is actually what is happening. Actually, students, just memorize it. This is a quick trick for you, that first write all the functional values: f of a plus h, f of a plus 2h, f of a plus 3h plus f of b. Then keep the coefficients of the first and the last term 1, and then 4 to 4 to 4. Start with 4, stop at 4. Okay, and then remember that because n is even, that is why this strategy will hold. Okay, this is a very simple trick to memorize the formula. Otherwise, you can also follow this way, that for odds and for evens indices, you are having the coefficient 4 and 2, and your index is starting from 0. All right, and ending at n. So both are acceptable, both approaches are acceptable. Okay, just write the formula correctly. Now when we apply the Simpson's rule on a problem, what will happen? We will simply enter the functional values into the formula, right? So let me take you to the exercise. Question number 8. Okay, you can see here question number 8 statement. We will not go through the entire question, but simply let us modify the question. Let us apply Simpson's 1/3 rule for n is equal to 4, for n is equal to 6 on this problem. What will happen now? If n is equal to 4, how would the formula look like? This, all right? And what will happen if I have n is equal to 6? What will happen if n is equal to 6? Can I apply Simpson's 1/3 rule? Yes, because n is even. Next question is that how many values are going to be there? So you can see here 5 for 4. Therefore, 7 for 6. Okay, so the number of grid points is always one more than the number of patches. All right, remember this fact. Now next the point is to solve the problem. You can see here 5 plus 3 cos x is the integrand, and the lower limit is 0, upper limit is 3. And let us solve it when n is equal to 4. Okay, so let me just type here the step size. Okay, so let me type here. B is the upper limit, 3, A is 0, the lower limit, N is, let us solve this problem first for N is equal to 4. H is the step size, H is B minus A divided by N. Okay, now you can even do it on a notebook. So please bring your paper and pen and solve this question now and send it to me today or by tomorrow morning. Okay, so now you can see here that what is H actually. I want to see what is H when n is equal to 4, H is 0.75. All right, now I want to write my X. X, remember students, X is always starting point, lower limit, double dot, upper, the step size, double dot, the upper limit. Okay, this way you can easily find X, or if you are using a pen and a paper, do it this way: 0, 0 plus h, 0 plus 2h, 0 plus 3h, and stop when you get b. Okay, so now you have here right, so now you have here x, right? Now I want the function y is equal to 5 plus 3 cos x. You can see here from the book 5 plus 3 cos x, and then of course you can do it manually. You can use your scientific calculator or you can use MATLAB to find the functional values at x. Remember to convert your calculator mode to radians. All right, so now you have here the functional values. Y is you can see the functional values here corresponding to the inputs x. All you need to do here, students, all you need to do here is you will substitute these values in this formula. What will you do? You will substitute these values in this formula and you will get the answer. Okay, so now you can even do it using MATLAB. You can even do it using a paper and a pen, right? So let me show you when I did it using MATLAB, and then of course you can do it using your pen and paper, right? So you can, I suggest that because you are learning the method, so do it on your notebook. What is the next task? You will simply substitute these values here. Okay, now the first question is what is b minus a divided by n and then divided by 3? So I have it as h by 3, which is 0.25. Okay, so I will write here 0.25 dot, because I'm using MATLAB, I will use dot static, and then functional value at the first point plus I will have 4 dot static functional value at the second point. I'm doing these things in a very simple way at the moment, but when we go through the lab contents, I will do it in using the MATLAB syntax for the indices currently, because you are learning the method for the very first time. Let me make sure. F of A plus 4 times f of a plus h plus 2 times f of a plus 2h plus 4 times f of a plus 3h plus f of b. And let us see what we get. 15.4242. Okay, now the next task is to change the step size and to change the number of segments. Let me make it 6. I am very confident then that now the step size will also change. What is h? H is b minus a divided by n. And I repeat, you can do these all on your notebook as well. So no excuse that you cannot use MATLAB, no problem, do it on your notebook. That is why I'm using a very simple syntax. You can write it on your notebook. Now the step size is 0.5. It is very obvious. 3 minus 0 divided by 6. Okay, now you have x as 0h3. Now let us see. Now you have 7x values. Now you will define again your function, and then you will get the functional values. Now the next task is to write the integral. Now what I had earlier, I had this as the integral. Now I will keep it in my mind that this number is actually h by 3. Okay, and what is h by 3? Let me just say h by 3. For new case, what is h by 3? H by 3 is 0.1667 because h is 0.5 this time. Okay, so now I will write this number. Why? Because it's the formula, they tell me that write outside b minus a divided by 3n or h by 3. Both have the same meaning. Please remember this, that b minus a divided by n and h are same. All right. So now let me go back to my formula. Now what am I going to do now? I will remove the percent sign, right? I will write here for your for your understanding. I'm doing it in a very simple way so that you can do it on your notebook. F of a plus 4 times f of, now this functional value will change. Okay, remember this. Let me just recall what was the functional value. Functional value is this. So now let me just type it here. Okay, so 4 times this value. Okay, do not make a mistake that you use the previous values now, because the step size has changed. The corresponding functional values will change. Okay. Now, students, I have more points. I will say 42424. Remember that, okay? So 2 times this value, 3.7516 plus 4 times 2.596. And let me check wherever I got at the last point. F of B shall remain the same. F of A shall remain the same. Okay, so let me first cross check whether my formula is correct or not. I had to write B minus A divided by 3n or H by 3 outside the bracket. Then I will have F of A plus 4, F of A plus H plus 2, F of A plus 2H plus 4, F of A plus 3H plus 2, F of A plus 4H, plus 4 F of A plus 5H, and plus 1 F of A plus 6H, which is actually F of B. All right. So now let me press enter. Now my answer is 15.4266. Okay, now remember that when we have n is equal to 6, how will the formula look like? Let me quickly type it here. Right, so the formula shall look like B minus A divided by 3n. Okay, so let me just now what will change? Here I will have by 3 times 6. Okay, when n is equal to, when n is equal to 6. And the formula will change. Now I will work for n is equal to now I will have 2 times f of A plus 4h plus 4 times f of A plus 5h. Remember, students, that f of A plus 6h is actually f of B. Let me write here. F of A plus 6h is actually f of B, because A plus 6h is equal to B, and in general A plus NH is equal to B. Okay, now this is the formula. Now you can see, students, now things are very easy for you. So there is no excuse that there was no internet, or there was a connectivity issue, or you had no MATLAB, or things like that. Many sad stories. So please work hard. You are the future mathematicians, so you need to work hard. Okay, I have solved the question for n is equal to 4, for n is equal to 6. Now you will ask me again and again, what is the homework? What is the homework? So let me write the question here. Solve it on a paper for n is equal to 4, n is equal to 6, n is equal to 8, and analytically, and send me today or tomorrow morning. All right, I am waiting. Thank you for your time, and do watch the video, do submit the homework, and work hard. Okay, thank you very much.